Introduction. Today weather is awesome. It is quite cool day. I think rain will start just now. We have to reach our home as soon as possible. Yes, you are right. Oh, rain has started. Brother, can I ask you something? Sure. As we know that clouds are in the sky and raindrops fall from the clouds, why raindrops always fall downward to earth? Why do not they go upwards? Okay, I will tell you. Raindrops always fall downwards due to gravitational force of the earth. The leaves of the plants also fall down on the earth due to the gravitational force. Anything thrown up falls down towards the earth. Okay, now I got the answer. Brother, I want to know more about this. Can you please tell me? Yeah, sure, Yash. Come, let's talk more about gravitation. Objectives. At the end of this lesson, you will be able to define gravitation, define Kepler's laws and gravitational law, measure acceleration due to gravity, measure acceleration due to gravity below and above the surface of Earth, define gravitational potential energy, learn escape velocity, know Earth satellites and their energy, know geostationary and polar satellites, define weightlessness. Definition. Gravitation is a natural phenomenon by which physical bodies attract with a force proportional to their masses. Gravitation is most familiar as the agent that gives weight to objects with mass and causes them to fall to the ground when dropped. Gravitation is responsible for keeping the Earth and the other planets in their orbits around the Sun and for the formation of tides. Kepler's law. Kepler gives three laws. They are stated as: Law of orbits. All planets move in elliptical orbits with the Sun situated at one of the foci of the ellipse. Law of areas. The line that joins any planet to the Sun sweeps equal areas in equal interval of time. This law comes from the observation that planets appear to move slower when they are farther from the Sun than when they are the nearer. Law of periods. The square of the time period of revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. Let t be the period of revolution around the Sun and r the mean radius between the Sun and the planet. T square is directly proportional to r cube. T square is equal to kr cube. Universal law of gravitation. According to Newton's law of gravitation, every particle in the universe attracts every other particle with a force directly proportional to the product of their masses and inversely proportional to the square of distance between them. The direction of this force is along the line joining the two particles. For the two particles of masses m1 and m2 separated by a distance r, F is equal to g m1 m2 upon r square. The constant g is called universal constant of gravitation. In spherical body, the total mass can be supposed to be concentrated at its center. For bodies of the other shapes, the distribution of mass needs to be considered. The gravitational constant. The constant g is called universal constant of gravitation. The universal value of gravitational constant is given by g is equal to 6.67 into 10 to the power minus 11 Newton meter square by kilogram square. Dimensional formula of g is m to the power minus 1 L cube t to the power minus 2. Acceleration due to gravity of Earth. When one object is the Earth, while the other is the body on or near its surface, then the force of attraction exerted by the Earth on the other body is termed as the force of gravity. Thus, the force by which the Earth attracts a body towards its center is called the gravity. A body of mass m placed on the Earth's surface experiences a force given by F is equal to G into MEM upon RE square, where m is the mass and RE is the radius of the Earth. According to the laws of motion, the body will experience an acceleration g due to this force given by G is equal to G into ME divided by RE square. Acceleration due to gravity below and above the surface of Earth. The value of g varies from place to place on the surface of the Earth and also as we go above and below the surface of the Earth. Variation with altitude. On going above the Earth's surface, the value of g decreases. For the body m raised to a height h above the surface of the Earth, the acceleration due to gravity is given by g dash is equal to g multiply by 1 minus 2h upon r. Variation with depth. As we go inside the Earth's surface, the mass of the Earth attracting the body towards its center keeps on decreasing and thus the value of g decreases continuously. For the body m at a distance h below the surface of the Earth, the acceleration due to gravity is g dash is equal to g multiply by 1 minus 2h upon re. Gravitational potential energy. Gravitational potential at a point in the gravitational field is the amount of work done in bringing a unit mass from infinity to that point. When a mass m is moved from one position to another position away from it in the gravitational field of another mass m, some work is done by the external force against the force of gravitational attraction between m and m. The work done gets associated with mass m as its gravitational potential energy. Thus, gravitational potential energy of a mass m at a point is equal to the product of gravitational potential at that point and mass m. Escape velocity. Can we throw an object with such high initial speed that it does not fall back to the Earth? Yes, if we throw an object with escape velocity, it does not fall back to the Earth. Escape velocity is the minimum velocity at which a body projected from the Earth's surface will escape the Earth's gravitational field. Escape velocity for the Earth is v is equal to 11.2 km per second. Escape velocity for Moon is v is equal to 2.3 km per second. This is the reason that Moon has no atmosphere. Gas molecules, if formed on the surface of Moon having velocities larger than 2.3 km per second, will escape the gravitational pull of the Moon. Example. Let's take an example of escape velocity. Calculate escape velocity on the surface of the Moon, given the mass of the Moon, radius of the Moon and value of g. Let's see the solution. Given radius of the Moon r is equal to 1.7 into 10 to the power 6 meter. Mass of the Moon m is equal to 7.35 into 10 to the power 22 kilogram. Escape velocity is equal to under root 2gr. By putting the value of g, we get escape velocity is equal to under root 2gm upon r. By substituting the values, we get escape velocity is equal to 2.4 into 10 to the power 3 meter per second. Earth satellites. Earth satellites are objects which revolve around the Earth. Their motion is very similar to the motion of planets around the Sun, and hence Kepler's law of planetary motion are equally applicable to them. Earth satellites' orbits around the Earth are circular or elliptic. Moon is the only natural satellite of the Earth with a near circular orbit with a time period of approximately 27.3 days. Artificial satellite is an object which has been placed into the orbit by human endeavor. Uses of artificial satellites are: Number 1. To study the upper atmosphere. Number 2. To forecast the weather. Number 3. To study cosmic radiation and radiations from the Sun. Number 4. To study the Earth's shape and explore the presence of minerals and water in Earth's upper layer. Number 5. To study the meteorites. Number 6. To receive and transmit radio, television, and telephone signals. Energy of an orbiting satellite. A satellite revolving round the Earth in a circular orbit has kinetic energy as well as potential energy. Since it is the gravitational field of the Earth, its potential energy is U is equal to minus GMEM divided by RE, where M is the mass of the satellite. The kinetic energy of the satellite is K is equal to half mv naught square, where v naught is its speed in the orbit. The necessary centripetal force for the circular motion is provided by the gravitational attraction. Kinetic energy of the satellite K. Total energy of the satellite is equal to kinetic energy plus potential energy. On calculating, we get total energy is equal to minus 1 by 2 GMEM divided by RE. Since the total energy of the satellite is negative, it implies that it is bound to the Earth. In order to free the satellite from Earth's gravitational pull, it has to be given energy equal to 1 by 2 GMEM divided by RE, so that its total energy becomes 0. This energy is called the binding energy of the satellite. Geostationary and polar satellites. The geostationary satellite, positioned some 22,223 miles above the equator, maintains its position by completing an orbit in 24 hours. The long-range view of the same area helps meteorologists to monitor, analyze, and predict weather patterns. However, in order to fully understand the Earth's atmosphere, the entire planet must be monitored. Polar satellites are those satellites which circle the globe in a north-south orbit, passing over the north and south poles. Polar satellites cross the equator at the same time daily. Using a pair of polar satellites ensures that the measurements for any part of the Earth are not more than 6 hours old. The area observed is much narrower, but has the advantage of greater detail. Weightlessness. We feel our weight due to the reactionary force exerted on our feet by the plane on which we are standing. If the plane on which we are standing starts moving with some acceleration, the weight felt will be different. We all have experienced it while coming down in a lift. However, if the ropes of a descending lift are broken, it will fall freely under gravity and our feet will not feel any reactionary force while standing on the platform of the lift. Thus, we shall feel as if our weight has become zero or a state of weightlessness. This situation is similar for a man inside a satellite. The artificial satellites are just like freely falling bodies. Did you know? Kepler Johannes is the best known for his discovery of the 3 laws of planetary motion, based on the painstaking observations of Tycho Brahe and his co-workers. These laws describe how the solar system is organized. The gravitational force is independent of the nature of the intervening medium. It is also independent of the presence or absence of other bodies. The force of gravitation between two bodies can be zero if the separation between the two bodies becomes infinity. The escape velocity is independent of the mass and direction of projection of the body from the surface of the Earth or any other planet. Summary. Let us summarize what we have learned. Gravity is the Earth's gravitational pull on the body lying on or near the Earth's surface. Gravitational forces do not depend upon the medium between the two particles. A uniform solid sphere of matter attracts a particle that is outside the sphere, as if the entire sphere's mass were concentrated at its center. The gravitational field strength at a place is equal to the acceleration produced in a freely falling body at that place. The orbital velocity of a satellite depends upon the mass and radius of the Earth or any other planet around which the revolution of the satellite is taking place. Earth satellites are objects which revolve around the Earth. Their motion is very similar to the motion of planets around the Sun. The polar satellite orbits in a north-south direction, as the Earth spins below it in a east-west direction. As a result, the satellites scan eventually scans the entire surface of the Earth.